Greetings, my little triglets. It is the Halloween season. So that means it's full of tricks and treats, but trig and treats is all that needs to go together here. So trig or treat, I think it's one and the same because trig is such a treat. All right, today I'm going to give you some notes. It's not going to be very long today because we are going to learn the graphing calculators tomorrow. Graphing calculators will do most of the work for us, but we do have to know where it all comes from. Now there are several types of solutions when we use a graphing calculator. The first type is called an integral solution. Basically, the root word for that is integer. That means it's positive and negative whole numbers. Another part of a solution or another type of solution is rational. A rational solution is basically a fancy name for a fraction. And then the third type is irrational. And that's things like square roots that don't have a normal square root. And other irrational numbers, pi would be another one. But that's pretty rare to see pi as one of our answers here. So, quick example. 5y equals x squared plus 5x plus 6. This is a quadratic. Factoring it, you break it down. The 6 breaks into a 3 and a 2. I need it to be 5, so they're both going to be plus 3, and plus 2 makes 5. So my zeros here are negative 3 and negative 2. Which one of these would that fit into? Well, because they're integers, they would be considered integral solutions. Okay. Now, when we do these on the calculator, we'll have something like x to the third plus 4x squared minus 7x minus 10, which is not as easy to factor. What it does factor to is x plus 1, x minus 2, and x plus 5. What you did last year in Algebra 2 or the year before was you found the common factors for this, 2 and 5 and 1 and 10, all plus or minuses, and you tried those in the press box and you found out which ones worked. Well, that was a lot of guessing and checking. The graphing calculator is going to give you these three answers on the screen within about 12 seconds. So you'll be able to come up with the graph pretty easily. And the graph itself you can do on the graphing calculator too. Rational numbers are just fractions, so sometimes they come out to be, if you had a 2x plus 1, the fraction would be negative 1/2 for the 0. Just set this equal to 0, and that's what you get for the result. So sometimes you're going to have rational answers. Now I want to do one that's irrational because those are harder to see on the graphing calculator. Let's say I have y equals x cubed plus 3x squared minus 2x minus 6. And all the factors of 6 are plus or minus 1, 2, 3, and 6. Now, for the sake of argument, I'm going to try negative 3. Let's say we looked at it on the graph and we noticed that the graph went through negative 3, but we're not sure what the other answers are. And remember, whatever this highest power is, that's how many answers you should have. That's how many zeros you should have. So what we're going to do is we're going to do the press box with the one that we know does work. So let's pretend that this graph looks like this, and this is at negative 3, but we don't really know what that one is or what that one is. So we're going to use our negative 3 in the press box. And we're going to do 1, 3, negative 2, negative 6. Bring down the 1, that's negative 3, 0, 0, negative 2, 6. And it better come out to be 0 at the end, otherwise negative 3 is not a 0. It's not a factor. It doesn't go in evenly. Now what's left these three it's called the depressed polynomial, because we just factored out one of the zeros, one of the x's. The rest are kind of depressed because he's not there anymore. They're taking away parts of their family. So what we're going to do is we're going to make this x squared plus 0x minus 2. We're going to set it equal to 0. And so x equals plus or minus root 2. So that's what these other two are. One's plus and one's minus. So the zeros are -3, root 2, and negative root 2. Those are the answers to this, the solution. That's what you would put in for x to make the equation come out to be 0. Okay, so tomorrow we're going to do these on the graphing calculator, but sometimes you have to do a little bit of algebra after you find one of these, because the square roots don't come out. You might see 1.414 dot 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 dot, and if you don't know what that, if that's square root of 2 or square root of 3, then you're going to have to do this, get it into the depressed polynomial and solve it from there by hand. All right, I want to do one story problem with you, and then we'll be done for the day. So let's say you have a piece of cardboard. It's 10 by 10, and you're working for a manufacturing company that makes cardboard boxes. And they have all these 10 by 10 pieces, and they want to make tops for boxes. And we know that the volume of the box or the top has to be 64 inches cubed. So that's all we know. But we have to make a top, which means it has to have sides. So we need to cut out the corners here so we can fold it and make a box top. So we have to figure out what those possible dimensions can be for those corners. So I'm going to call the corner length x. And they're all the same. Now, volume formula for a box is length times width times height. So volume we already know is 64. Length we don't know, width we don't know, and height we don't know yet, but we can figure that out from our picture. So if I have 10 inches here, but I cut out an x and an x from either side of it, my length is going to be 10 minus 2 x's. And I'm going to do the same here. This is 10. Take away the 2 x's. That's your width. Now the height is when you bend this corner and stand it up straight. So then your box top looks like this, where this is the 10 minus 2x. This is what the corner was cut out. So that's just plain old x for the height. So now we have an equation. I'm going to FOIL this out. I'm going to do these two first, and then I'll distribute the x into it. So I have 64 equals 100. Then I have minus 20x, and another minus 20x, and then a plus 4x squared. Okay, looks like we're getting a quadratic because of that. Now you need to get like terms together. So I'm going to move things around a little bit. The 64 I'm actually going to subtract from both sides and get 0. So I get, oh wait, let me back up here a minute. Okay, I am going to rearrange this a little bit first. So I'm going to make it 4x squared. These two together, I'm going to make more 40x. Then I have plus 100, but I'm going to subtract I'm getting stuck here with the x. Oh, I know what I have to do. This x I need to distribute first, so let's back up again. My bad. Okay, so I need to distribute the x throughout all of this first. So 64 equals 100x minus 40 x squared and then plus 4x to the third. Okay, now I'm going to rearrange things. So I'm going to put the 64 is going to come over. I'm going to start with this, 4x cubed minus 40x squared plus 100x and then minus 64. Now I noticed that they all are divisible by 4, so I want to do that before I start. It'll make the math a lot easier. So x cubed minus 10x plus 25x minus 16. All right, so this is where you're going to put it on the graphing calculator, and then you're going to come up with some answers. Because it's to the third power, there'll be 3 answers. And this is the way the graphing calculator will show them. It will show 1, 2.44, and 6.56. So you go to your boss and say, okay, I found some dimensions we can use, and you give him these 3 answers. And your boss said, you're fired. And he, wait, why? He says, well, one of those answers is just ridiculous. And you look at it and go, oh yeah, I can't have this one because if I put 6.56 in there, I'm going to have a number bigger than 10, so I'd have a negative distance. That does not work. So these 2 are the only 2 that are going to work. So if x is 1, I would have a 1 by 8 by 8 box top. If x is 2.4 or 2.44, I would have a 1 or a 2.44 by 5.12 by 5.12. So depending on what size box you want, you know, whether it's tall and skinny or flat and short, you can choose between those 2. So it's all algebra until you get to this point where you want to find the values of x. Then you go to your calculator and type it in and it just spits it out for you. It's kind of nice. All right, that is it for today. If you have a graphing calculator, bring it in and we'll continue this conversation tomorrow. Ta-ta for now.